अस्सलाम वालेकुम students. Integral equation के chapter number 2 method of converting initial value problem into Volterra integral equation. In this video we will do this method first, and then we will do another question, that is you have to convert the given differential equation with initial conditions into Volterra integral equation. And after getting the Volterra integral equation, you have to drive it conversely back to that given differential equation. So first of all, come to this first example. We have y double prime plus y equals to 0, and the initial conditions are y of 0 equals to y prime of 0 equals to 0. First of all, y double prime equals to minus y, integrate both sides. Initial condition is 0, so it will be from 0 to x. Y double prime means second derivative, so it will be reduced to the first derivative, and then you have to apply the upper limit and then the lower limit, the limits of integration. So it will be y prime of x minus y prime of 0 equals to minus integral from 0 to x y of x dx, and we know that y prime of 0 is equals to 0, so plug in the value here. So we will be left with y prime of x equals to negative integral 0 to x y of x dx. Now you have to again integrate this equation. You have to integrate unless and until you are left with just y of x. So when we will integrate it again, this is dy by dx. So it will be left with just y of x. You will use the upper limit x and the lower limit as 0 because the initial condition is starting from 0. Here you already have an integral, so you have to put the another integral with some other variable like 0 to xi y of t dt, and then according to this xi you have to put dxi. Integral 0 to x y prime of x dx equals to, now we know that we can convert the multiple integrals into the single integral. And what's the method? You always have to write x minus t. How many integrals are there? 2. So you have to write 2 minus 1 over 2 minus 1 factorial this y of t dt. Now here you have dy by dx, first derivative. When you integrate it, you will be left with just simple function y of x. So y of x with upper limit minus lower limit y of 0, and plug in the value of y of 0, that is, you know that y of 0 is equals to 0. And here after simplification we will get minus integral 0 to x minus t y of t dt. After multiplying the negative sign we will get this integral. We have just rearranged it. You can mark it as kernel of xt, where kernel of xt, k of xt is t minus x. Now we can try same way this question. You can try it at your own. Just try it once and compare it with this solution. After that, we have to do this question, that is, they're asking us to convert the given differential equation with the initial conditions are these into Volterra integral equation of second kind. So you have to integrate it again and again to get the Volterra integral equation. And then conversely, whatever Volterra integral equation you will get, you have to apply the Leibniz rule. You have to differentiate it to get back this equation. So first of all, we are doing its first part, integrating with respect to x both sides. You know that it's the second derivative, so it will be reduced to the first derivative only by putting the upper limit minus the lower limit of integration. You know that initial condition is starting from 0, so you have to integrate it from 0 to x. Then minus 3 y prime of x dx, and we know that this is the first derivative, so it will be reduced after integration to y of x minus the lower limit y of 0, plus 2 integration of y is y of x dx equals to integration of 4 integral 0 to x sine of x. So sine of x has integration cos of x, and I have not used the upper and lower limit right now. I will use it in the next step. Now we know that y prime of 0 is already given in the question, that is negative 2. So plug in the value here. We know the value of y of 0 given in the question, so plug in its value here. After using these values, just look at on the right side. We have used the upper limit first and then the lower limit, and then just simplify it. After simplification, we will be left with this equation. We are going to again integrate it just because of this derivative. We have to finish all the derivatives. When we will integrate, this is the first derivative, so it will be left with just the function by putting the upper limit minus lower limit. minus 3 integral 0 to x y of x dx plus 2 0 to x and then 0 to xi y of t dt dxi. And then you have to integrate cos of x, that is, you know, that sine of x, and integration of 1 is x. In the question you are given with the value of y of 0, just plug in the value here and then convert this multiple integral into the single integral. And how we can convert it, you know that I have already showed it to you in this first example as well. We can convert it this way. So it will be always x minus t. There are two integrals, so power will be 2 minus 1 like this, divided by 2 minus 1 factorial equals to minus 4 sine x minus x. Now we are just simplifying it and just rearranging it, and after rearrangement we got this equation. This is the Volterra integral equation of second kind. Why it's second kind? Because you can see that the unknown function y is appearing under the integral sign as well and outside the integral as well. Now conversely, consider this Volterra integral equation and we have to go back to differential equation. So first of all, differentiate it, and you know that how we can differentiate it. Y will be y prime, it means dy by dx. Derivative of 1 is 0, derivative of x is 1, and derivative of sine x is cosine x. And derivative of this integral. Now this complete function inside the integral is your f of x. This is your function. We are going to use here our Leibniz rule. And what Leibniz rule says? We have to take partial by partial x of this complete function, then plus this complete function, replace the t with the upper limit x. So replace this t with the upper limit x, replace this t with the upper limit x, and derivative of x with respect to x, minus this complete function but replace the t with the lower limit, and then derivative of your lower limit 0. Now just rearrange it, take the derivatives. We know that here it's going d0 by dx is just 0, and this term is 3y of x you will be left with, and dx by dx is just 1. Just rearrange it, we got this equation. Now again you are left with one integral here, so again differentiate it. So when we'll again differentiate it, single derivative will be converted into the double derivative. Derivative of minus 1 is 0, derivative of cos is minus sine, derivative of yx is y prime. And when we will take the derivative of this integral, we will again use the Leibniz rule. Take the negative 2 outside and use the brackets. Partial by partial x of this function y of t, then plus y of x. Now you have to replace in this function in place of t the upper limit. So y of x and derivative of upper limit, minus y of t will be replaced with the lower limit and derivative of lower limit. Just rearrange, you know that this is not depending on x, so its derivative is going to be 0. So this complete thing is gone to 0. And this is also 0, and dx by dx is 1, so you're left with just this. Just rearrange it. So this is the same differential equation that was given in your question. Now we need some initial conditions, and initial conditions must be on y of x and on y prime of x. Initial condition will be 0, so plug in 0. Put x is equals to 0 on both sides of equation 1 and 2, and we will get, you know that you have equation number 1. So when we will use the 0 here, we will get the y of 0. So simplify, wherever you have x, just plug in the 0. So we will get here y of 0 as finally 1. And then in equation number 2, for y prime of 0, put the x as 0. So we will get here 0 here, and the integration from 0 to 0 is also 0. So you will get here this thing. So these are your initial conditions. And now you can try this exercise 2. This exercise 2 is based on these starting 2 questions that I have explained you in this video. You can just note down these questions and you can try doing these as a practice.